Fantastic. Okay, so hello everyone. My name is Divesh Gokul. I am the lead automation developer at VMO2, and I'm here with my colleague Shankhanil Chaudhry, who is the enterprise architect. So today we are going to go through one of the automation use case that we have delivered for VMO2, and it is a provisioning of a Doxy service. Before we start with the Docsis automation, if I go to the next slide, let me give you a quick background on who we are as a company. So Virgin Media is the fastest major broadband provider and the best mobile network operator in the UK. We would be able to see some of the figures on the screen, which should give you an indication of the scale of the company itself. Okay, so if we move on to the next slide. So Docsis is one of the key technology that we use to provide our customers broadband, TV, and phone services. The new Docsis standard, allows us to kind of, basically it supports up to 10 gigabits per second speed downstream capability and up to 6 gigabits per second upstream capability. And we have hundreds of CMTSs in key strategic location around the country, and they provide thousands, actually tens of thousands of serving groups. The configuration lines to spin up a serving group can be huge, which means that it is easy to make mistakes, and it can be time consuming as well, to come up with a design for each of the serving groups that we want to spin up. So this is a couple of the key reasons why we thought, it is a kind of a prime candidate for automation. So if I'll now pass over to Shankhanil, who would explain our journey from where we were to where we are going to be, and also touch on why we chose the tools that we did. Shanks, over to you.
Yeah. Thanks, Devesh. So this slide just talks about some of the actors and levers involved in provisioning a Docsis service. And it was a very heavily manual process with many manual touch points, prone to many errors, and was very time consuming. So you had a design engineer who would maintain spreadsheets for the frequency plans and parameters across the UK. So every region in the UK would have a specific frequency plans, specific frequency parameters that needed to be coded for devices in that region. We had a backend engineer who would collect data from a multitude of sources, from OSS systems, in-house tools, Visios, and Excel sheets, and create a configuration item that they would then push to the device via CLI while on the call with the field engineer. So there was this tight coupling between the backend engineer and the field engineer. The field engineer would rack, stack, cable the kit, and be on a call with the backend engineer while he generates that config, pushes that config, troubleshoots that configuration if issues happen, run some tests, etc. So there was this tight coupling. And what we saw was that with the design part, because it was maintained in Excel spreadsheets, there was a lack of standardization. There was no single source of truth. There was problems in version control, etc. And with the backend and field engineers, obviously there was a very tight coupling. It was time consuming. It was prone to human errors. And most importantly, there was a lot of security vulnerabilities, and there was a lack of security auditability on the network because of this particular paradigm. So if we can move on to the next slide. So this is the problem that we are trying to solve. And this is how we solved it. So we chose IAP as the service orchestration layer in Virgin Media O2, and NSO as the network service orchestration layer. So now in this new paradigm, you decouple all of these actors. So a design engineer can create those design parameters using IAP workflows and create those design parameters in something called the network design table, which is a central repository version control for all the frequency plans and parameters across all regions in the UK. And now the backend and field engineer are also decoupled. The backend engineer can create jobs in IAP and a field engineer can execute jobs in IAP. So it allows field engineers to self-serve. So what we have in IAP is workflows. We have workflows configured to configure the Docsis service on the network. It talks to NSO through NSO adapters. And in NSO, we have three key things. We have the network service model for a Docsis service, which is modeled in Yang. We have the configuration templates we want to use to configure those devices. And we have the logic to populate those configuration templates in Python. We also have the network element drivers for our CMTS estate. So we have two major vendors there. And we have the relevant CMTS NEDs for those vendors. Now, the idea was that through this pattern, through this paradigm, we can ensure consistent network configuration across the estate. We can eliminate our human errors. We can improve security and ease the auditability of the network. And at the same time, we have a central repository of all our design parameters, right? So this was developed in Virgin Media O2 by a dedicated team of automation engineers and developed by two dedicated developers in 4 sprints, which shows you the speed at which you can develop on this platform, which was critical for us because we wanted to get to market with this automation quickly because these pain points were causing us a lot of money and wasting a lot of time for our engineers, right? So on to the next slide, Devesh. I just want to highlight why Virgin Media O2 chose a combination of IAP and NSO. And out of the many reasons that we have, I just want to focus on the two biggest reasons, which is, I guess, the key takeaway here. The first one is network engineering friendly, and it links to the rapid rollout as well. The IAP's low-code platform and NSO's platform are very network engineering friendly. What that means is you can get your Docsis engineers, your design engineers to upskill and dabble in network automation quickly. And that allows us to rapidly roll out these use cases and be highly effective in automating network services. So on to the next one, Devesh. Yeah, so we have a demo for you. Devesh, you want to lead on that?
Yep. So the next step is that we're going to show you a demo. And as part of the demo, we will go through the process, as in the implementers logging into Itential automation platform, also known as IAP, and uploading jobs. Field engineer claiming those jobs, running, well, the pre-checks run as well in the background, which you don't see, but I will explain in the demo. You will get to review the config, which is in the form of dry run. And then eventually, when you're happy with the config, you will be deploying the config onto the CMTSs. And then there are some post checks that happens to make sure that the config that you have actually deployed is correct. I'll briefly touch on what is the network design table and what sort of lookups happens in that table. And then we'll talk around the NSO service itself, what it is made up of, the components that it's made up of, including the Yang model, the templates, and the Python script, and also how we're using action as well, as part of the end-to-end process. Just to note as well that some part of the config and IP addresses shown in the demo had to be, masked, as we were advised to do so by the VMO2 team. Nicholas, do you want to play the demo, please? Hello, everybody. Today, I'm going to demonstrate the automated provisioning of a Doxy service through the use of Itential automation platform and Cisco NSO. The Doxy service that we will provision is more specifically to spin up a new Doxy serving group by configuring a MAC domain. And it's worth pointing out that a MAC domain is capable to serve over 600 customers. So the first step of the automation process is to ask the customer for their intent, i.e. what do they want to provision, and get them to provide the minimum information required to provision that service. So the implementer would provide this information through a spreadsheet, where each row of that spreadsheet represents a job. And an example of that spreadsheet is on the screen. And in this particular case, we are configuring two MAC domains on the two CMTSs, with the associated parameters like number of downstream, number of OFDM, etc. So once the implementer have completed this form, then they will log into this platform called Itential, and they will say they want to provision a Doxy service, and they will upload the customer input form that they've just populated. And this just gives them the confirmation that the job has been successfully uploaded. And now when a field engineer or physical engineer logs into Itential using their own sets of credentials, they will be able to see the two jobs that's been created on IAP, and they would be able to kind of progress it all the way through to completion, so completing the instantiation of the service onto the CMTS by going through a series of parent-child structured workflow on Itential. And IAP in itself has the ability to make API calls into other systems and also make database queries as well. And that is actually the first thing that it does to get the necessary information it needs to create an enriched set of data that is then used to construct the RESTconf payload needed when instantiating the Docsis service on NSO through its northbound interface. And the database that we have chosen to use is MongoDB, and we've called it the Network Design Table, NDT. We use it to store all of the site level and region level frequency plans. And for us, this solves the problem of having a logical engineer having to go through several spreadsheets to come up with a logical design with the right frequency plan for the device and the MAC domain that they are trying to configure. The NDT is the single source of truth for frequency plan, and is being kept up to date by the logical design team themselves. I can show you a quick example of how the NDT looks like. So what you see on your screen here is an example of how the NDT look like. So Itential will make a query. First thing it goes to is the site capability, and it will try to look up in this array of items here, where is the site that concerns us, so the signs that we are trying to provision, and that's based on the prefix. So the host name has the first four letters, which represent the site. And once it comes here and it gets all of these information, then it uses this set of information as well as information that was on the customer input form to make a series of other queries to gather the enriched data that it requires to instantiate the service. So now if we go back on IAP, when the physical engineer selects the job, they actually will be prompted with some forms. Well, first of all, the prompt says that this is the device that you're going to be configuring, this is the MAC domain you're configuring on. Once they are happy that this is the right job, then they will populate it with some of their details, and also given the choice of whether they want to view the generated dry runs for that particular service, or they want to be emailed the post check. So once they've actually selected this and hit submit, then the workflow will take them through a series of stuff. And one of the things that it will actually do is it will go and it will do a pre-check. So what it runs is what we call a command template on Itential, and what that does is it runs a live status command on NSO to the device to find out things like whether there are existing modems on that MAC domain. And if there is existing modem, obviously, that fails the pre-check, because we don't want to kind of go and configure the MAC domain if it already has modem on it. The next thing that happens is we are going to trigger a cleanup service. So this makes sure that the MAC domain and all other associated configuration blocks, associated with the Docsis service, are set to be in a clean state without any, residual config that might have been left behind by engineers. And that also paves the way to achieving a fully compliant CMTS. As we, at that point, then we will know that only known templated config would eventually be present on the CMTS. So if I open my CLI, right, so I am actually tailing the log here. So you can see this is the Docsis cleanup log that I've just loaded. So if I click submit here, after going through the pre-check, if everything is okay, as in there's no modem on the MAC domain, then as you can see, it goes and does the cleanup service, and we can see some references to that service, like for example, this is the device that we are going to be configuring, and this is the MAC domain that's being cleaned up. This is the upstream controller as well, and that's the service. That's the service name. So this takes a few seconds. After this has been done, then the next step in the process is to actually provision that MAC domain with the serving group related information, and we're going to see that in a second. Okay, as you can see, now we're starting to configure the actual service that provision the MAC domain, and this is the path of the service. This is the MAC. This is the device that we are trying to configure. This is the MAC domain, and all of the associated information to actually create the service. And these are information that we have got from the customer input form. We have transformed. We have enhanced or enriched so that we can provision that service. So if we go back to Itential now, you would see that we now have a dry run. This is the dry run of the service, and it shows you the configuration that was generated, and it's going to be applied to the device if we hit accept. Okay, but before we do that, if I go to visualize to look in the workflow a little bit, so you can see that I have done my pre-check. If everything is successful, then I do the cleanup service, and I am actually then using all the data that I've gathered throughout the queries and information gathering. I am actually adding my Nso payload. So if I look here, this is how the Nso payload looks like. So we've got, that's the service path. These are the MAC domain. This is the fiber node information, and you will actually see all of these in the service model that I'm going to show you later on as well, the YANG model. And this is a container in the YANG model. These are the leaf nodes. This is another container, for example, etc., etc. So if I go back to manual task here and I accept the configuration, that will start applying the configuration onto the device, right? So if I go quickly to the CLI and I move to the device, and I SSH into it, show running config interface cable 201 is what we are configuring. So you can see right now the interface itself is empty. So if I hit accept here, you would start seeing, you see the log again for that service. The first one obviously went through with an option of dry run, so it only displays the dry run, whereas this one at this time it's actually going to push the configuration to the device, and we're going to start seeing the config appear on the interface shortly. Obviously there is other side of
other config blocks that's also getting applied. We saw that in the dry run, so it might be doing the other side. Now we can see the interface is actually being populated with the configuration. So this again takes some time. It takes a few seconds, so we will wait for that to finish. Right, so now the service has completed, as in the provisioning has completed, and what we've done is we've executed a series of live status command to make sure that the service that we have provisioned is actually correct. So you can see that we have executed the show controller integrated cable, and then the MAC domain is basically parameterized. So in fact, MAC domain is the main parameter for that the template is using. And this is basically our post check. So once we are happy that everything is normal and everything is appearing as up, then we can hit OK, and that basically completes the instantiation of the service on NSO, and we know that everything is good. So the NSO service itself is made up of three main components: the YANG model that describes the service, the configuration template in XML, and the script. In our case, it's a Python script that has all of the relevant logic required to populate those templates. So if you take a look at the VS Code, okay, so this is the service, and like I said, we have the Python script that sits within this directory. And that's populating these sets of templates, with the necessary parameters. As I mentioned before, the Docsis service is quite big. So what we've done is, instead of having when templating that configuration, instead of having a monolithic big template, we've broken it down into several smaller templates to make it more manageable. And obviously each of these templates have variables that we are passing it from the Python script. Some of them are basically just being passed through the customer input form. Some of them are coming from the network design table, but we also have those that we are calculating. And one example is the upstream controller that we have calculated based on the MAC domain ID, right? And then we have these tags here. So the US channel that in the config itself repeats on several lines. So instead of repeating it on the template, what we're doing is we've added that logic inside the Python script. So if we take a look at the script here, so you can see that we're actually going through that loop and adding all of the necessary parameters, including the channel ID, and then applying the template, which populates the first go of the template. Then it goes back in the loop, adds the relevant information, and populates the next set of tag on that template before we have the complete templates, which we would then apply when we're instantiating the service. So the other piece of the other component, as I described it, is the YANG model. So this is here, and this is the name of the YANG model. This is the module, and we have defined some custom parameters that are relevant to our service, and we've also grouped items together that can be used in several other areas, like for example several other containers, and they each have constraints as well, where we thought it is necessary, that prevents wrong configuration to be applied to the device. It will actually stop it from actually doing that. So actually this is one way of seeing the YANG model. Another way you could visualize it is in a tree manner. So if I go to my CLI again, you are able to kind of do pyang -f tree. In fact, I have it in my history. So pyang minus f, and this, well, this shows you the whole tree, but you can use it with the option of tree no expand uses, and that will actually give you you know, just the a subset of the yang, not the whole tree. And as you can see here, we have the service ID, you know, that you can see here. This is the service itself. It's a list. It's got the key, that's the key here, and the key itself is a leaf. You know, we have the device, which is a leaf ref, which you can see here, and then the fiber node, which is you know, made up of a leaf object, and this is a group called fiber node parameters. You see, it uses this this group, and it also uses this OFDMA group, right? In the previous view, you could actually see all of the details. So it doesn't show you the group, it shows you all of the details of the parameters. So for example, look here, fiber node, you have the enable leaf, you have the upstream channel count leaf, etc. So this is the YANG model for the service. Other than service, we also have actions which we would actually be using instead of using the command templates that I showed you on Itential. And an action is quite similar to a service in that it also have a YANG model. If I actually open up an example of that, of the one that we are currently working on. So this is the YANG model, and you can see this particular action takes takes 2 to 3 input. The first one is the device, and the second one is a check type, as in what is the sort of checks you are looking to do on the device. Is it a MAC domain level test? Is it a device-centric test, or is it just license related test that I want to run? If it is MAC related test, then we ask for the MAC domain as well. And obviously MAC domain has some constraints, just like you would add in a service. We've also templated, we also got some templates here. These are TextFSM template. So when we are running the show commands, there's a list of show commands that we run. So for example here, show controllers, integrated cable, all of the commands that you saw previously on that we ran through the command template. But we are also able to pass the unstructured output onto TextFSM to get more of a structured output, which we can then use we can use Python to extract the relevant information, and we can then compare it against expected values, which we have kind of defined by working alongside our SMEs in the Docsis area. So this wraps up the demo. I hope this was useful to you, and thank you for listening.
Yeah, so thank you for listening to the demo. So provisioning the Docsis service, automating the Docsis wasn't always plain sailing. We did have to, you know, we came across some of the challenges, and what I've put on the screen for you is a few that I just wanted to share with you guys. So the first challenge was the fact that we had variables and parameters that depended on areas of where the CMTS were, and also parameters that were dependent on the CMTS platform itself. So the solution that we found for that was creating a database instance for the frequency plans, and that's what we call the network design table. And like I said, the configuration lines itself for provisioning a MAC domain is huge, it's enormous. So because we have to configure the downstream, upstream, bonding groups, controller interface, fiber node configuration. And the solution that we had for that was to kind of modularize everything and breaking the configuration line into templates, adding all of the complexity inside the Python script. And at the end of the day, what we get was a simplified customer input form with a network design table and a Python script, which gives us the configuration lines that gets applied to the CMTS. And the other challenge that we faced was that sometimes with the CMTS, because engineers are often on the device configuring it, we tend to have existing residual configuration on the Mac domain, uh, and which do not kind of follow our desired config structure. So the approach that we have taken is we've used kind of a wipe and deploy strategy, which again I've shown in the demo. And in terms of the net development itself, especially because it's a multi-vendor environment, what we have to do is plan ahead and make sure we cover and explain all of the interdependencies, i.e. the order of the configuration, and provide the net developers, the Cisco net developers, access to our network, and give them all of the relevant commands needed, and encourage net developers to test their fix on the relevant platform before passing it over to us and releasing it to us. So that's me. I just want to pass on the next slide to Shanks to conclude the session.
Yeah, so this is how we engage and work together. So we have a dedicated team in VMO2 that is dedicated to network automation. We have adopted the Scrum framework for agile software development. We have all of these customers in the B2B wholesale consumer engineering line of businesses, and they come to us and give us requirements through a demand gate, and the product owner owns the backlog, grooms the backlog. We work in 4-week sprints. We have a team of in-house developers developing most of these use cases. And we work with IAP and NSO consultants that guide us, that give us the support. We have 24/7 support from IAP and NSO. They guide us on the best practices, how to do what's right. They align our roadmap where we want to go with their roadmap and point out where there are efficiencies. They do release management, tell us what's coming up in the new release and how it can help our use cases. They focus and expedite the bug fixes, the bugs that we identify in the platform. And they provide training to our engineers so that we can upskill new joiners, etc., quickly and get them up to speed with what we are doing. And finally, I would just like to say, with this automation use case, Docsis automation use case, there are a few key benefits that we have brought to each player that we talked about, or each actor that we talked about, using IAP and NSO. So for the backend engineer, as you have seen, we've minimized the number of entries that he needs to do. And we've also given him the capability of bulk uploads, right? So he can upload a series of tasks that can be executed later by a field engineer. For the field engineer, we have allowed self-service, so it's not dependent on a backend engineer, and also can run auto pre and post checks. And as you've seen in the workflow, we guide the field engineer through the whole process through the dialog boxes. So it's an interactive journey for the field engineer as well. And he can see what's happening at each state and interact with the automation suite at any point. And then for the design engineer, obviously we have a centralized version controlled repository of all your design parameters. And through the workflows, we can validate and upload the data into the entity in a controlled manner. And finally, for the business, we reduce our bad costs and we prove that automation works on the most complicated service we offer using IAP and NSO. So that has been a win, a major win for us. And with that, I conclude. I open the floor to questions. Anybody has any questions, please feel free to ask.
Excellent, thank you. I think you answered my questions, at least with the challenges that you described. So very well. We have time for one question before we have the next speaker up. So thank you. If you don't have any question, I don't see any raised arms. So with that, thank you guys so much for presenting from UK. It was very interesting to hear your use case on Docsis. Thank you.
You're welcome.
Thank you.
Thank you.
Everyone. Cheers.